Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO here at NextGen Agri International, where we help livestock managers get the best out of their stock. Before we get started, thank you to our two fantastic sponsors for continuing to sponsor this podcast. MSD Animal Health is perhaps better known as Cooper's Animal Health in Australia and for their Allflex range across the world, with a comprehensive suite of animal health and management products. Honiger is a one-stop shop for wool harvesting and animal fibre removal. The Honiger team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Welcome back to Head Shepherd. Ferg here. Great to have you listening along as usual. This week on the show, we've got a great guest, Kelsey Bentley from Kansas State University. She's just finished a PhD not that long ago at West Virginia University in the US, obviously. And a really interesting chat, which I'll get to in a minute. Before we go there, this week on the Hub, we've released an article. It's called Selection Strategies for Regenerative Farming. I sat down and sort of thought about how people might approach genetics if they were interested in regenerative farming. And I know that's a broad school of thought, and there's kind of everything from what we might call conventional right through to regenerative, and I think everyone sits somewhere in the middle of that. And so, and I'm far from an expert on regenerative farming systems, but thought that people that were heading that way would be interested in reducing chemical use, maybe antibiotic use, so how genetics might help that strategy. And so sat down and wrote an article on that. That's on the Hub now, so you can jump on there and have a read. We'd love to hear your comments, your thoughts. Obviously, I don't run a regenerative farming system, and we have got people within our clientele that are heading that direction. Obviously, most of our clients are generally grass-based, but some are using some of the concepts that I guess you would call regenerative. I'd be interested to hear your thoughts. Before we quickly get into Kelsey's episode, just want to welcome Sophie to the South Island. Sophie moved this week down to Curacao, so it's awesome to have her down here with us now. We are going to backfill, or we're going to put someone up in the north coming soon. You'll hear more about that in the next couple of weeks. We'll have Emma on as a guest and talk through her new role in the north. But yeah, great to have Sophie a bit closer to us, and really looking forward to having a bit more personal contact rather than just over Zoom and Riverside. But yeah, if we get on with this week's show, Kelsey Bentley, I really enjoyed this conversation. She's done a lot of work around immunity and immune function in sheep, and some of the really interesting findings that we're going to talk about in this podcast. I could have talked to Kelsey for hours, and hopefully we'll get that opportunity going forward. We're going to hopefully have Kelsey join us live on the Hub as well. So yeah, watch out for that. That's going to be great. But yeah, the link between worm resistance, immunity, colostrum, lamb survival under disease challenge. It's a pretty cool space, and something that I think we're really going to lean into as an industry, and sort of partly prompted me to write the article this week around regen farming and thinking about how we build these sheep that require less labour and also less chemical inputs, which is something that all of us are trying to do as we try to keep check of that rise in costs that we've all seen over the last few years. Righto, we'll stop talking about it and get on with this week's show with Kelsey Bentley. Welcome, Dr. Kelsey Bentley, to Head Shepherd.
Thank you.
Great to have you, Kelsey. So yeah, the reason we've got you along today is because your PhD topic is really interesting, and so we were keen to have a chat about that. You're the small ruminant extension specialist at Kansas Uni, what are we?
Kansas State University.
Kansas State, sorry. I have got this written in front of me and just didn't find it. But have moved from Virginia recently, which is where you did your PhDs, which is where we're going to chat mainly about. I mean, maybe just a bit of your background, how you ended up interested in sheep and worms.
Yeah, so I was originally from North Carolina, where I grew up on a club lamb operation. So really immersed in sheep and goats, even from a young age, growing up through 4-H and FFA. And then eventually figured out that I wanted to make a career out of sheep, and kind of in order to do that, realized that I had to leave the state of North Carolina. So under the mentorship of Dr. Scott Rowdridge, would go on to get my master's degree originally. And then I applied for a fellowship through West Virginia University and would go on to actually receive that fellowship. So that's how I ended up sticking around and getting the PhD.
Yeah, cool. So the club lamb operations, that's breeding animals for that sort of show circuit. Is that what that means, or is that
Yeah,
something
so
different?
it's just like blackface crossed influence sheep, yes, for
Yeah.
mainly show. So that's actually how I started. And then on my research is where I actually, that was my first introduction to Katahdin sheep. And I grew to love them and realized that, man, these are really cool little critters, and decided that, that was kind of an avenue that I needed to explore outside of just the club lambs.
Yeah, yeah, awesome. Yeah, most of us over this side of the world look at the club lamb with
Yeah, yeah.
a slight smirk, but yeah, cool. Like, maybe just explain the Katahdin sheep, their sort of background and their specialities.
Yeah, so originally developed by Michael Peel out of Maine. He wanted to combine some of the traditional growth traits that we see in wool breeds, like the Suffolk, with some of the easy care and no shearing characteristics of breeds like the St. Croix or Barbados Blackbelly, and decided that, hey, I'm going to start crossbreeding these to see if we can get a really low input, kind of easy care sheep. And out of that, ended up creating what we now know as the Katahdin. It is the fastest growing sheep here in the United States with the most. And the way I measure that is through National Sheep Improvement records. So from I think 2018 to now in 2023, they have the most lambs on record, and are just by far taking over National Sheep Improvement Program in terms of registry. So something that is really popular here in the States, and that we really like to see grow.
Cool. So they are used as a maternal breed or a terminal breed, or
Mainly
both?
maternal. I
Yeah.
think that they actually do get docked somewhat here in the States when it comes to, having the tail and being a traditional hair breed. It just kind of depends on where your market is. Some more ethnic markets actually prefer the Katahdin, whereas a lot of the more terminal markets will maybe try to shy away from them. But you're seeing more of the Katahdin kind of push its way into traditional kind of sheep enterprises within the estates.
Yeah, cool. So they're obviously sort of had performance at their core since inception. So obviously lots of work done, and one of their strengths is their resistance to worms. That's sort of been built into the breed from day one, or is that sort of?
Sort of, kind of. So you have to think of the Katahdin. They get the reputation for being parasite resistant. However, we have to remember that I talked about two breeds kind of on the spectrum of parasite resistance. So you have the Suffolk breed, who in the United States is known to be parasite susceptible. So they're not very good at combating that parasitic infection. But then you also have breeds like the St. Croix and Barbados that we know grew up in environments that forced them to be better in terms of their parasite resilience. So the Katahdin actually has a lot of different breeds of resistance and susceptibility nested within them. So it's very important that we don't just go along and tout the Katahdin as being parasite resistant in general. And that's why it's important that we start to measure traits like that so that we can select for Katahdins that are more parasite resistant. Now, producers in the States have actively been selecting for the Katahdin to be more resistant to parasites. So if you had to ask me if you would say that the Katahdin is a parasite resistant breed, I would say that thanks to the producers in the States, we do now have a Katahdin that is more parasite resistant than I would say they are susceptible. However, there still are Katahdins out in the States that are still susceptible to that parasitic infection.
Cool, good answer. We never get away from the bell curve in genetics. We're always there's always variation. Yeah, so that's excellent. We're big fans of resistance to parasites, which is why we're chatting, and I guess the ability to breed an animal that requires less labour and less chemicals to stay healthy and happy and productive. I guess most of us, including me, I don't understand it that well, is like the mechanism of resistance to parasites. What's going on in an animal when it manages to reduce the worm population within itself and then within the population? What are the mechanisms that it can use to cut down parasitism?
Yeah, so there is so many. It's kind of you can think of it as almost twofold. So there's an initial cascade, which is going to be mainly like cellular based. So those are going to be things like neutrophils that are going to put out extracellular traps and kind of bind up the parasite and prevent it from moving or growing or reproducing. And then the body naturally kind of sweeps that parasite out and it subsequently dies. So you can think of that as more of a cellular based immunity, but then there's also humoral based immunity in which that individual can go out and actually tag the parasitic antigen with antibody and state, hey, we figured out that this is foreign, and that antibody kind of does the same similar mechanisms of entrapment and then subsequent sweeping of that immune responses. There's lots of different immune cascades. There's cytokines like IL-13 that have this weep and sweep response where when parasitic antigen kind of interrupts the endothelium or kind of irritates it, IL-13 can be produced, and then we get lots of mucus production and then the sweeping of those parasites out of the immune system. And what you would kind of see as diarrhea, but it works kind of twofold as a means of us as producers don't like to see the diarrhea. However, naturally, that's that individual trying to get rid of the infection.
Yeah, cool. So it's that mechanism that ends up sometimes where you see a positive correlation between worm resistance and what we call DAG, which is diarrhea, or measure how we score as DAG anyway. So that mechanism is why we sometimes see that correlation, whereas others, and we have been actively breeding against that correlation to try and get animals that are resistant to worms and don't scour, which is kind of the holy grail for us. Interesting stuff. If we get into, I guess your PhD was around what's going on in the immune response, and I mean, in all sorts of detail. I guess the interesting stuff is, and we're seeing it kind of loosely and really keen to understand it more, is as we select for worm resistance, we get kind of a bit more general. I don't know, we seem to get a better immune system somehow. And we're seeing that in foot rot a little bit. So there's a favourable correlation between resistance to foot rot and resistance to worms a little bit in the work we did in New Zealand. And we're also starting to see, Catherine McRae has shown it. There is a favourable correlation with pneumonia in New Zealand, and we're sort of starting to see that a little bit in our work where some sires have just seemed to be healthier progeny. Talk to us about what's going on there.
Yeah, so I'll tell you kind of how we stumbled upon it through my master's program. So it was actually work predicated by Dr. Andrew Weaver, who is now currently at NC State University. And what he found was that lambs out of low PFEC, so that's going to be post-weaning fecal egg count. So that's an EBV that we generate from NSIP. So sheep that were incredibly negative in terms of that value, sheep that were sired by a negative RAM, meaning that he should have parasite resistant, had lower percentage of death loss at this one particular research facility that we were looking at in kind of that Southeast Virginia. And it was interesting though, because that timing of death loss was right around weaning. So it was from day 7. So it was non-neonatal death loss. So it was from day 7 to right around weaning. And sheep would have not experienced a pasture-based infection yet. So it kind of got us wondering what exactly was causing this really high death loss this particular year. And it was actually found to be Clostridium perfringens type A. So the CD&T vaccine covers the traditional C and D with a tetanus toxoid. However, that type A isn't really included. So they had a particular rainy season at this unit, and there was an outbreak of Class A. And what happened was parasite-resistant sheep died less from the Class A. So that got us, saying like, wait a minute, that's non-parasitic in nature. That's actually a bacteria. So how are these sheep managing to overcome that kind of dirty environment with the Class A? And so I started looking at response to CD&T vaccine in those lambs and saying, okay, well, let's measure their response to vaccination and kind of see what that looks like. So what we found was that parasite-resistant lambs who had that incredibly negative post-weaning fecal egg count EBV responded to initial vaccine in this kind of small manner. It was rather minor. However, upon booster vaccination, they had this huge amnestic surge of antibody, which meant that those individuals immediately recognized that CD&T vaccine upon booster and generated lots of antibody to it. Now let's talk about the problem. So the parasite susceptible sheep, or those that were incredibly positive in terms of their post weaning fecal egg count EBV, did not respond to initial vaccination. So that line from initial vaccination to when the booster would occur was relatively flat, meaning that those individuals never really took in that antigen and processed it. So therefore, whenever they were boosted, they couldn't nearly have the level of protective antibody needed, indicating that maybe these individuals might have actually required a third booster to get to the protective level of antibody needed. So it kind of just, that was our down and dirty way of measuring those individuals' ability to respond to what we knew that they were dying from. And we found that the parasite resistant lambs were much better equipped to respond to the CD&T vaccination as opposed to the parasite susceptible counterpart.
That's really cool, isn't it? Like, it's so awesome when it's so infrequent in science where you stumble across really cool things like that. So you must have been pretty pumped when you got to do a PhD in that area.
Oh yeah, we were stoked. It was one of those things where when we saw the differences in terms of death loss, we kind of suspected. However, it needed to be taken that step further, and so yeah, that was my initial master's project, and what a great master's project to have.
Yeah, cool. Is there any reason, and I'm thinking the answer is no, but I should ask the question, that is Katahdin specific? Like, obviously your work's been in Katahdin, but is there any reason why that would be the case?
Yeah, I get that question so much, and it's tricky. Right now, we can't say it in breeds much outside of the Katahdin.
Yeah.
It's relatively confined just because my whole entire dissertation did nothing but focus on Katahdin sheep. But the main purpose behind that is because we have such a beautiful breeding scheme set up where we have parasite resistant and susceptible individuals all
Yeah.
within the same breed. So that's why the most exploration has been done there. However, we are, now that I'm at Kansas State University, I'm going to try to explore that in breeds outside of the Katahdin, mainly starting with the polypay. We're going to try to set up a similar system here where we have parasite resistant and susceptible polypays and see what occurs within that breed.
Yeah, excellent. That'll be the thing to watch closely. Was it you or a colleague that did the work into colostrum? So
it was also me. Yeah.
Let's talk about that.
Yeah, I'll puff out my chest a little bit about the colostrum. That was actually my brainchild. So, kind of, the transition from your master's to your PhD. Your master's, you're kind of, set up for success. They want to give you something that they think will be, and I was, it was like, wow, what a great. But then the PhD, my boss kind of sat back and said, now it's time for you to start to think about some things that are, how are you going to contribute to the industry? And so with that death loss, that initial death loss, my kind of take on it was that I thought that, they were giving Sire a lot of credit for the influence of that. But I was like, but what about like DAM? Let's take a step back and think about what DAM could be providing in that mating. And a lot of that early initial death loss, I thought could actually be contributing to the influence of colostrum. What is DAM passing through colostrum that's allowing those sheep to better able to survive? And that kind of, once again, just snowballed into something that I couldn't have even imagined. But where we started was we said, okay, we're going to take 20 of the susceptible ewes, 20 of the resistant ewes, and we're just going to take colostrum samples on them. And we're going to do a colostrum sample, but then we also wanted to see like the impact of antibody across lactation. So we decided to do a 30-day sample and then also a 60-day sample. So we called one an initial kind of a colostrum sample. Then we also had a mid lactation and a late lactation sample. And what we found was that in that initial colostrum sample, there were massive differences in terms of antibody. And we were almost shocked. I went back and actually did the assay again in a previous year just to make sure. And so now what we can say is that at this particular unit, when we look at colostrum, there's a 2.5-fold difference in terms of IgG between parasite resistant and parasite susceptible individuals. So not only was the lamb's ability to respond to that CD and T vaccination playing into the death loss, but the ewe or dam was also having a huge influence on that lamb's ability to be able to survive in a dirty environment or an environment that was rich with pathogen load.
I mean, simply put, I guess if there's you had a passed on, I mean, essentially more of its immunity, so that first vaccination is actually a booster to a lamb that's already had some antibodies passed from mum. Is that how that works? Or
Exactly. So mom is able, and the great thing about mom kind of passively providing that immunity is that if she's in the environment that we are going to now dump lamb into, so lamb goes
yeah,
from totally sterile environment to now
yeah,
dirty environment. So her cells will go out and they will sample little pieces of pathogens that she will have encountered throughout her lifespan, and they'll hold on to them. We call them B cells or plasma cells, and she'll remember what that pathogen looks like, and then she'll generate antibody to that pathogen. Well, the great thing about colostrum is that is what lamb is getting. So lamb is getting kind of this repertoire of antibody that mom has experienced. And those, having more of that antibody means that you are better equipped to handle those pathogens. So mom is just giving lamb all of her immunological memory by that initial colostrum. That's why, when you hear, oh, colostrum is an important, it's very important from a nutritional sense, being that it's complete nutrition for lamb. However, people often kind of glaze over or don't think about the immunological consequences of colostrum. And I think that by lamb ingesting those antibodies, there is so much programming that goes on that we haven't even began to scrape the surface of. So
yeah.
just thinking about lifetime productivity and how that individual is going to be throughout their entire life. Do parasite resistant sheep, are they early maturing? Do ewes have more days of it's such a interesting kind of thing to think about. But I think all we can say for right now is that those sheep have a better start in life.
It is super interesting. Like, this possibly my favourite science day ever. It's such a cool area that we've just, as you've said, is sort of sitting relatively untapped. We've sort of blindly bred for worm resistance for one purpose, but if we're accidentally getting all sorts of other cool stuff, again, there's not many free lunches in this game. So when you get one, you've got to run with them. The IgG, which is a word I can't say, immunoglobulin something or other. Talk to us about. Yeah, that's the increased count. So that's essentially the parcel of immunity, is it?
Yes. So IgG is the highly specific form of antibody. So there's all sorts of antibody. There's IgM, which is like this big pentamer that just kind of grabs things and says, "Hey, I'm big, so just come find me." There's IgA, which is a little bit more of a mucosal secretion. So we also looked at IgA within those early samples and found some differences in IgA as well. So think of saliva or mucus or even colostrum. But then IgG is very, very specific to either colostrum or serum. It's highly abundant, especially to very particular pathogens. So it's kind of the most specific form of antibody that we could find to say, okay, when we're measuring immune response, we didn't really want to go with IgM. That's just kind of a surveilling antibody. And then IgA too is just a little bit, it's too broad. There's not kind of enough specificity there, but IgG would be the highly specific form of antibody that we could measure.
So in a production system where we're often vaccinating for, as you say, the user in the production environment, in the dirty environment, but also we obviously pre-lamb vaccinate for Clostridial. And so what should happen, or what you've seen happen in Katahdin, is that those worm-resistant ewes mount a bigger response. They'll also then pass on more of that vaccine or that immunity from the vaccine to lamb.
Yeah, exactly. So they just have more antibody in general. So not only do lambs die less, they respond better to vaccination, and then they also have more IgG within their colostrum.
So good. What are I'm feeling like there's got to be a but here somewhere. Is there any downsides of this? Is there any any outcome that we don't want?
So Dr. Nodder at the University of Virginia, he's emeritus now. However, he did put out some data that would say that maybe selection for immune response is not necessarily conducive of growth. So it's kind of, we think of it as a resource pie. So if, you have this big pie and you take up a larger piece of that pie in resources devoting towards antibody production, which is a protein, then that individual may be less likely to experience better traditional growth traits. However, my data, and I actually had to present my data in front of him, and it was kind of terrifying. But my data says that
he's a nice guy. He's not that terrifying.
No, he's not. But just because we have selected for one, we don't necessarily impact the other, and that was on a very small scale. But that does need to be done just to make sure that when we are selecting for immune traits, we're also selecting for well-rounded individuals that are in fact, not just going to, but I think that's actually a part of the fault of the Suffolk is they never actually able to shift from traditional growth to mount an immune response. They just can't physically do that. And so therefore they never mount the immune response and they die. So it's still important to have both. I'm not saying that we just need to single trait select for immune response. However, we need to keep that in mind too whenever we start selecting for individuals. We can't just solely select on growth or maternal traits.
Yeah, and I think that's the job of animal breeders is to work with correlations and bring it all together rather than one or the other. And I think there is work that Joanne Grief and John Carlson have done in Western Australia where you kind of separate there is a growth penalty when you run them with susceptible sheep, but when you separate them out and they run together and they kind of have that opportunity to control the worm population, then they actually don't need to mount their immune response because they're kind of getting rewarded for their effort of their immune system. So like the growth penalty then goes away if you run them and with them with like with like, I suppose. So that's I think there's probably that makes sense in a resource allocation sort of theory anyway.
Yeah, exactly. And then just one more thing that we didn't touch on that was in my dissertation. We then went back and said, okay, let us look and see when we do challenge these individuals with an immune response. We wanted to see behaviorally how they responded, because when you think about it, sheep that appear more sick are more likely to receive a treatment. So we're like, well, let's just look at these, and very interesting things in terms of behavior as well. Those parasite resistant sheep are far less likely to have a duration and severity of sick behaviors when we give them lipopolysaccharide, which is just a bacterial agent that kind of makes them feel really physiologically ill. They're able to bounce back from that not only quicker, but they also show less severity of sheep grimace score. So for people who want to kind of see the full picture, not only do we know that all of these sheep are healthier from an antibody sense, but when those sheep do eventually become sick, they're less likely to receive that treatment because they appear less sick.
Right. This is so cool. So what's I guess that's where we're at. So the lamb mortality, I think the lamb mortality it's towards the end of, it's not neonatal mortality. It's kind of somewhere in that pre-weaning phase, but it's not they're better at getting up and surviving under a cold stress. It's obviously more of a pathogen-related survival.
Yeah, it's definitely a pathogen-related survival because, like I said, we track that survival number at that particular unit across multiple years. And that one particular year that I was talking about where death loss rose to like 40%, that was atypical. And then, of course, it returned to more of a normal level. And there were no differences between the sheep whenever they weren't challenged with that dirty environment, as I like to say.
Yeah. And I think that's kind of what we're trying to set ourselves up for. I mean, there's years where things happen, like it could be a wet summer in Australia and New Zealand where all of a sudden you've got a whole heap of pressures on that you're not used to, or a really cold winter or whatever. Like I guess we need to set the sheep up that like every sheep can go well in a perfect environment, but it's when things don't go well that all of a sudden you're in a lot of pain, and for things like that, there's no treatment often. Like it's selection of the fittest in a really expensive way.
Yeah, exactly. And I feel like there's some producers out there that just think, oh, this is the way it has to be. I'm just going to have sheep that die. And my research would kind of tell you that maybe if we start selecting for that post-weaning fecal leg count EBV, you're actually getting health traits along for the ride with that. It's not just selection for parasites. It is selection for when you have those bad years and you do have a class A outbreak, or you have incidents of pneumonia within your barn. My research would start to tiptoe that line of, I think it's when we select for parasite resistance, we're getting individuals that are in fact healthier to a variety of pathogens, whether it be parasitic, bacterial, or viral in nature.
Yeah, which is interesting. Across parasites, I don't know the US very well at all, but so where we have some areas which are more Ostatagius or scale worms, and then some Barber's pole areas. What typical parasites are you dealing with?
Yeah, typical within the United States, definitely from an economical sense, are homuncus. That's definitely what we're going to be mainly focusing on and dealing with. That's not saying we don't have any of the Ostratagia around here. It's just not as predominant.
Yeah, okay. Yeah, right. You got the nastiest one, so that's handy. Yeah. Cool. So I guess what's next in terms of, given obviously you got to keep, now you have to keep a job and you'll have other stuff to do, but what would be your sort of research projects going forward if given funding and given the opportunities?
Yeah, so right now, currently, I just put in a proposal. Actually, I'm hoping to start to. So I talked about that response to CD&T vaccination. I feel like that's such a good starting point for us to look at antibody in breeds outside of the Katahdin. So we know what the Katahdin does in response to that CD&T. So now I put in a proposal for Rambouillet, Polypay, Targi, Dorpers, just to get in some samples from different producers and start to look at IgG levels right following initial vaccination and then also following booster vaccination to see if we can't kind of then look back into NSIP and kind of post hoc say, okay, well, individuals within these breeds also have better response to vaccination. And then also the colostrum. I mean, as I spoke about previously, I have just scratched the surface of colostrum. I think it is a biological masterpiece that I pretty much plan to spend the rest of my career focusing on and seeing if we can start to uh, parse apart some of the biological underpinnings that are going on in colostrum consumption.
Cool. Well, that's awesome. We can watch it for the next 30 years, providing some great research. Maybe longer. Awesome. The CD&T, I'm assuming that's kind of like our 5-in-1. That's Clostridial. Is that a combination of Clostridial vaccinations?
So like I said, it's the Clostridium perfringens type C and D, and then also a tetanus toxoid. So it's just a really basic vaccine that's given over here in the States. And so it kind of gives me a good starting point of it's something that producers already implement, and then I can, on the back end, do research from that.
Yeah, cool. What's the lab costs for testing? Is that prohibitive or not too bad?
It's not too bad at all. I make all the plates in-house. So me and Dr. Baldridge actually kind of, we made that plate so specific. And it's like, I tell people, like, when you first started doing it, it seemed like I was trying to reinvent the wheel. But now that I've done it so much, plate is super cheap, really inexpensive. And because that's the first thing producers, when I want serum samples from them, they're like, oh, well, what's this going to cost me? And the plate itself really isn't expensive at all. I think when we calculated it up, it was maybe $1.25 per plate. But when I say per plate, I think there's 48 samples that can go on that plate. So producers can get a lot of really good knowledge, and too, it helps that I am just now starting up in terms of my career. So I'm able to maybe offload some of that cost on the producer and state it as a research purpose. But I eventually hope to maybe start to see some of that cost actually go towards implementation into NSIP. Like I want us to have reported IgG values within the National Sheep Improvement Program. I'm sure that's so far down the road, but certainly within my career, that's something that I would like to see implemented as a really good way for us to start to select for healthier sheep.
Cool. And so it's just blood serum that you need? Like you just spin down blood, take serum, and no, you don't spin it. You got to wait it. You got to coagulate it and take serum, do you?
Yeah, it's as simple as that. It's just a serum test, nothing. Because the colostrum, I will say, when a producer kind of comes to me and says, "Well, I want to do some colostrum stuff," the colostrum's harder. There's a lot of fat, and you have to dialyze it out, and it becomes a whole nightmare. But no, the serum IgG, it's mainly just training someone to draw blood, because I feel like that's not a super common practice among most producers. But if they're close enough, I'll go to them, draw the blood, spin it down here at K-State, and then have some results back for them.
Yeah, cool. Very, very interesting. And so the result is obviously a linear result, or is it sort of so you get a number from 1 to 1,000 or something, or what's the scale you get the results in?
Yeah, so it's nanograms per ml. So I think we found like individuals, and like I said, it's all relative to the Katahdin, so it's super hard because I don't want to throw out like you
random
get
numbers.
this amount. You get this amount of IgG, and you have a really good, because who knows, like maybe that's only relevant for the Katahdin. Maybe another breed has a different IgG value. It just all depends.
Yeah, cool. So interesting, Kelsey. It literally has been my favourite conversation for a long, long time to learn more about that. So really appreciate your time today. I better let you go and do some work, or you probably, I don't know, where are we? You're probably knocking off for the day, eh?
About to. It's 4 o'clock, so I've still got probably a good hour's worth of work, and then I'll head home for the day.
Excellent. That's been fascinating, and congratulations on some breakthroughs, and a great thesis, and really looking forward to watching that career, and my mind will be racing for the rest of the day, so expect an email before the day's out, I'd imagine.
Thank you so much for having me on. I really appreciate it. It's always great whenever you get to talk about your work.
Excellent. Brilliant. Thank you. Thanks again to Heinegger, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Thank you to MNSD Animal Health and Norflex Livestock Intelligence. They offer an extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. We thank both of these companies for their ongoing support of the Head Shepherd podcast.